Trigonometric equations. Trigonometric equations are just the same as equations we solved in the material covered in algebra and are solved using the same principles. The only difference is that you will end up with a trig function equals a number instead of x equals a number. You then need to go one step further and find the angle or angles that solve the equation. Example 1. Solve the equation 2 cosine x minus 1 equals 0 for all x where x is greater than 0 and less than 360. Solution. 2 cosine x minus 1 equals 0. Now our goal is the same as with an equation, to get cosine x by itself on one side of the equation. So we add 1 to both sides and we get 2 cosine x equals 1. And we say, well, we got to get rid of the 2, so we divide both sides by 2, and we end up with cosine x equal 1/2. So now that we know what cosine x is, we have to determine what x is. What angles between 0 and 360 have a cosine that's equal to 1/2? Well, first we can find the acute angle that equals 1/2, and we should have that memorized. And that x equals 60 degrees. So 60 degrees is our reference angle, or the angle whose cosine is 1/2. So now we have to determine where else between 0 and 360, what other angle has a cosine of 1/2. Well, we have to look for some place where the cosine is positive, because we have a positive 1/2. Well, in the second quadrant the cosine is negative, in the third quadrant it's negative, but in the fourth quadrant it's positive. So what angle in the fourth quadrant has the same cosine as 60 degrees? That'd be 360 minus 60, so it'd be 300 degrees. So our two answers for the original equation are x equals 60 degrees and x equals 300 degrees. Example 2. Solve the following quadratic equation, finding all the values in the given domain. Sine squared theta equals 3 minus 2 sine theta, where theta is between 0 and 2 pi, and also equal to 0 and 2 pi. Okay, since this is a quadratic equation, we're going to set it equal to 0 and try to factor it. If we can't factor it, then we'll probably use the quadratic formula. So let's see, does sine squared theta plus 2 sine theta minus 3, is that factorable? Yes, it is. Into the quantity sine theta minus 1 times the quantity sine theta plus 3. And you can multiply that out to see that it's true. So now we have to determine what's going to make each one of the factors 0. Sine theta equals 1 would make the first factor 0, and sine theta equals a negative 3 would make the second factor 0. Now what we've done is exactly what we would do if we would have had x squared equals 3 minus 2x. In fact, let's take a look at that on the right. That's exactly how we would do it, and if you compare the two, they're identical, except in place of x, we have a sine theta as our unknown. But now we have to go one step further here, because we want to know what theta is, not what sine theta is. Where with the x, we were done. So now let's see. Sine theta equals 1. What could theta equal? Now you're supposed to have that table memorized, so you should just know is equal to pi over 2. So if theta is equal to pi over 2, is there any other values between 0 and 2 pi where the sine theta is equal to 1? Note, it's very helpful that you can make a quick sketch of the sine, cosine, and tangent to help you answer many questions. In this problem, we can see there's only one place in the given range where the sine is equal to 1, and that's at pi over 2. So there's only one solution for that part of it. Now if you look at the other part, sine theta equals -3, what do you think about that? That's right, we have to reject it. The range of the sine function is from -1 to 1. And since a -3 is not in this interval, we need to reject this answer. So we only have one answer, 0 equals pi over 2.